Good morning, everyone. I'm Wei-jen Huang, and with Scott Paulsen, we're thrilled to introduce to you Fast Verify, our lightweight automated testing framework designed to bring unprecedented efficiency and reliability to platform validation. As you can see from the puzzle pieces, Fast Verify is built on key principles. It's easy to integrate, highly portable, inherently modular, and leverages JSON for data structures. Our core mission is to streamline the test and validation process, especially in today's very complex hardware and software environments. So why do we create Fast Verify? The primary driver was the critical need for robust and efficient verification on platforms like the Cisco 8501, particularly those that run CentOS 9. We face significant challenges with traditional validation methods. With raw CentOS installations requiring updates and custom utilities, there was a clear lack of a unified infrastructure to efficiently verify commands and system states. Existing tools like Sonic's ShowTech were used for quick snapshots, and Diags provided deep component-level testing, but neither offered the high-level automated and adaptable validation we needed across diverse scenarios. We needed something that could bridge the gap, providing quick go, no-go decisions without the overhead of full diagnostics, and doing so in an automated, repeatable fashion. This brings us to the core problem. Why does high-level platform validation and consistent data collection matter so much? In today's fast-paced development and deployment cycles, rapid and reliable feedback is paramount. Fast Verify provides quick tests for go, no-go decisions before committing to deeper, more time-consuming testing. It captures output from all the commands run, making it incredibly adaptable for various testing needs. It runs standard command line programs and crucially verifies both the return code and the output against expected patterns. For context, we developed this with OCP-inspired Cisco 8501 products in mind, specifically the 64 by 800 gig product line, which demands rigorous and efficient validation. Now I will hand over to my colleague, Scott Paulsen, and he will provide more details about Fast Verify.
Thank you. So Fast Verify overview. At its heart, Fast Verify is a lightweight automated test framework. It allows for high-level validation, mostly targeted towards Linux open source platforms. The key design principles we included with this are portability, as we wrote it in Python, so it can be easily ported from various platforms, modularity, as our test cases and output are written in JSON, and ease to integrate. Since it's written in JSON and Python, it's easy to integrate and move around. It's easy to integrate with, say, a web UI or other environment, as JSON is easily used in web browsers and can easily be parsed via machine or even user readable. So portability and customization. We can expand this using libraries and external scripts. As the test cases are written, they can be more complex by adding, actually calling scripts instead of having it just call programs. It does have a way to add libraries, so it can do more complex things. The main use cases that I've used it for above and beyond just the 8501 are multi-case processes where I have a wiki that will give me 10 different steps to do something. I can then put them in this script and then have it check each of the results as it goes along, and I can see that at the end it can validate all of the steps as it goes along. So if there's a problem, then I know right away. It can be done for quick regression of an image. If it can test, since it can look at the output to various commands, I can have it check things like sensors to validate that those are being read correctly, things like that. And of course, finally, we use it for manufacturing in our 8501 product, where it goes through and gathers a whole bunch of data, which we then check as it's going through, and then it stores that we can go back and look at it later if some issue arises later. So the workflow for this process is we first develop all the test cases that we want it to run. Say if we wanted to look at sensors, we'll have it run a program that outputs all the sensors, and then we'll have it check the various outputs of those sensors. Say if the output will say print a warning, we'll have it check for warning or fail or error or critical, and if it finds any of these keywords, we can have it fail. So we know right away that something is wrong. So once we develop all these test cases, then of course we can run it through the Fast Verify engine, and it can go through and check it, and then we get our results file, which we can then look at. It also prints it out on the screen as it's going along, so you can see exactly what's happening, and you can kind of get a go, no-go type of output. And then, of course, once it's run, we can look at and review our output, feedback our insights, and then rerun the whole process again. So comparing it with other technologies, say Showtech or diagnostics, the primary goals of Fast Verify are high-level testing, running Linux commands, looking at the output. A lot of the utilities we needed to run for this particular environment were actually command line utilities. Diags is typically more of a looking at libraries or hardware or APIs and validating specific systems. Showtech really is kind of more gathering system state that can be used for troubleshooting either now or later, but it requires a manual process or some other external entity to go in and look at that data to actually troubleshoot what's going on. The level of detail that we get from each of these, Fast Verify is high-level command output verification. Diags is kind of more deeper, component level, library level, those sorts of things. And snapshot configuration for the traditional Showtech. Portability, since Fast Verify is written in Python, it's very portable. Written in JSON, you can easily adapt tests to new environments. Of course, you have to update the test vectors, but that's usually pretty doable. Traditional Diags is typically hard-coded or written to a specific environment, and if it moves to a new environment, it needs to be rewritten or modified fairly significantly. And then, of course, Showtech really depends upon what OS it's running on. The Showtech for, say, Sonic is going to be very different than a Showtech, say, for FBOSS or XR or something else. Some of the strengths, Fast Verify, as I say, it's easily automatable, human readable, machine readable. Diags, it can get exact errors down to component or library or API levels. Showtech gathers a lot of information, but you have to go back and parse it later. So this picture I kind of like because, as I was mentioning before, if you have a whole bunch of commands you need to run or a wiki that has a whole bunch of different steps, you can go and copy those one by one, and you make messes as you go through, and it's kind of can be somewhat chaotic if you make a mistake and miss a step or whatever, right? But if you put it all into Fast Verify into the sequence and then check for the results. A lot of times just checking for return code of 0 is enough, so you don't necessarily even need to put anything in it since that's the default. And then you can quickly get your results. So you can just run it and you know whether or not everything is good. So it makes it nice and clean, like a checklist. Test vector definition file. So this visually encapsulates the transformation of Fast Verify brings, moving from a manual mess to a complex, error-prone manual testing to automated mastery. That's so this file is really more of a has the base directory where the output would go, what error file would go into it, where all the errors would go in that file, and then I have each of the commands that it would typically run. So I think of these as groups, right? Uptime would be a group, commands would be a group, and then what commands it would run inside each of those. So in this case, it's just uptime. This is a very simple example. It can be a lot more complex, obviously. And then the output file that it would output to. Now the commands, I have echo 1, echo 3. So then I can check for the output of that, right? If I see 3, it's going to fail. If I see 2, it's going to ignore that particular line. If I see 1, it's going to pass, right? And it'll allow for error codes 0 or 3. So if it sees either of those error codes, it'll allow it to pass. Now in this case, of course, fail is going to take the highest priority. So if it sees 3, it'll fail. So that's the definition of the input vector. So the output, as it's going along, you can see on the left-hand side, I have the output as it would be displayed on the screen. Obviously, it's a little bit less structured, but it tells you at the bottom how many test cases passed, how many test cases failed, and how long each of the groups took. And then on the right is the output JSON file of what it would look like when it's run to completion. And you can see some of them passed, some of them failed, and it also gives the percentage passed, percentage failed. So the roadmap for this and open source plans. So there's a call for feedback and contributions. Our goals, of course, is innovation, collaboration within the OCP community. It's currently available in Open Compute. I'm currently going through the approvals process for it, but I believe you can still access it through this link. I do have the sample YAML file with all of my basic examples here that I can make publicly available. And you're free to download it and take a look and modify it as you see fit. So I did create a short demo to kind of show it running through completion, if we can get that to run. And in this, I kind of show the configuration, each of the commands that runs as it goes, it displays it as it goes, and then it shows the output, and I also show it in a browser. Is there a way we can make it run? Oh, it's the one on the right. Oh, there it's going. So here, this is the input file, which has all of the input commands. This is it running, and you can see it displays a line for each command as it runs, and then a summary of the how long each group took, how many test cases passed, failed, and then it also displays all the ones that errored out, so you can quickly deduce the ones that failed. When I was going through this offline, I could see this a lot closer, sorry. So this is the output JSON file, and this has all of the same thing we were showing in the earlier one, but it's just showing this one was generated. You can see the pass, you can see the fail, number of errors, and things like that. As well as the various times. And then I show, here's it in a browser. So the file, you can go through the same thing in a browser, and you can see how many passes, how many fails, what the test cases were, how long each command took to run, and things like that. That pretty much covers it. Okay, so call to action. So I've shown here some pretty simple use cases for this, but they can be expanded quite a bit, and I have done a lot more test cases externally as well, or internally. Other test cases, right, like I said before, where multiple steps are required, you can very easily chain them together, and it will check them as it goes through. Also, it can be, if you put out the right test vectors in there, you can have a quick go, no-go type of decision for right after you build an image, or check it before you release it, or if you want to do more testing, right? So I load up my image, I'll run something like this before I go and run more complicated tests, because if I made a typo or something is wrong, I can find it very quickly before I go into more complicated tests. And of course, combining cumbersome steps that can be verified as they're run. How to get involved, check out the samples provided, find new and creative ways to use it, and of course, check it out at the GitHub link here, which I've provided, and hopefully you can find uses for it. So in summary, the key takeaways are that it's easy to use, it's portable, it's modular, and of course, since it's using JSON and YAML files, it's very easy to adapt to different environments and read in test cases and look at the results. The value add to Cisco and OCP users and developers is it's easy to use, adopt, and it's very extendable. And thank you for attending our talk. And if there are any questions, thank you very much.
Hey Scott, thanks for the presentation. Very interesting tool. Any thoughts on the applicability of this tool for CI/CD regressions?
Yes, actually, we do use it for CI/CD in the image that we have for our CentOS. We actually run it as part of our nightly runs, and then we actually have another tool that above and beyond Fast Verify that goes and checks all the basic steps for a basic pass-fail. We have another tool that'll go in and deeply check all of the outputs. So things like EEPROMs, which we just print here and check for, say the checksum is bad. We have another tool that then runs later and actually goes in and checks all of the fields to those to make sure they're good.
Thanks.
Thank you.
Any other questions? All right. Thank you guys so much.
Thank you.